Ladies and gentlemen, hello and welcome back once again to the only coast to coast radio show that's all about the information economy. It's time for Inside Analysis. Yours truly, Eric Kavanaugh, is here with a real mover and shaker in the industry, folks. I'm very excited to have David Flynn with us today. He is the CEO and founder of a very interesting company called Hammer Space, and they're doing some absolutely fascinating work. So, in the data world, we've been working for decades to get the data where it needs to be for the purpose intended. Data warehousing was invented largely because people realized you couldn't query these analytical or you couldn't query these transactional systems. That's not what they're made for. So we pulled all this data out, used all sorts of ETL to move it into relational models and then enable people to do analysis on it. There have been several movements since then. We've seen VMware come along, for example. We've had the whole Hadoop movement where we tried to fit all this data into the Hadoop or the highly distributed file system, Hadoop distributed file system, HDFS. But these were all shortcomings in a certain sense. In other words, they never really got to where we wanted to be. And the company we're talking today, Hammerspace, and David has done something that I think is may well have solved this conundrum. So, David, welcome to Inside Analysis. Tell us very quickly about Hammerspace, maybe where the idea came from and what you folks are working on.
Well, thanks, Eric, for having me on. Yeah, hammer space, first, the name, we didn't invent that. It's actually a term that has been used to talk about the extra dimensional space where magicians can pull things out of thin air. So it's like hyperspace for sci-fi and for travel. Hammer space is for fan fiction and the superpower of accessing an alternate universe in which you can store things. So if you pull something out of thin air, where did it come from? It came from hammer space.
That's
And we
very
use
cool.
that term to talk about what we do with data, because now data is no longer bound to the physical universe of storage. It was a very adept analogy that you used with the data warehouse. That
Hmm.
is what in the structured data world
Hmm.
people use. But
Hmm.
here we're talking about unstructured data, raw file data. And the reason why that's relevant is because with AI, we can extract value from unstructured data, images, video, media, documents of any type. It no longer has to be rigidly structured for there to be value. So then the question is, how do we do, the equivalent of what a data warehouse did, but for unstructured data, especially when considering that you can't afford to make copies of it
Right.
because this is much heftier than structured data. And so what Hammerspace does is we aggregate data across all of your existing storage and leave the data in place while creating a single logical view and the ability to consume it with extreme levels of performance from where it sits distributed in storage systems.
Hmm.
Um, and this allows us to project that data across whole different data centers and now move the data at the swipe of the mouse. So this isn't just about creating a unified logical view to physically distributed data. It's then about being able to control the layout of the data on the infrastructure through policy so that you can manage where the data is going to live. We talk about that as data orchestration.
Yeah, I mean, that's a really, really big deal because historically, as I mentioned, we used technologies like ETL or ELT when the cloud came around. I remember Synopsys, bought by Oracle, they did the ELT. Let's extract, load, and then transform it in the target environment. But you're
Yep.
still just moving data around and around and around.
And
My other
again, that's all
show,
structured data. That's not the low level unstructured file and object data.
right? Well, and that data that you're talking about, the unstructured file data, that's the kind of data that AI really wants to consume in order to train these huge models, right?
Exactly. And you talked about Hadoop because that was one attempt to solve the problem by creating one massive commodity storage pool that you could dump everything into. The only
Hmm.
problem is you're going to access it over Java and through the low performance. It's not a real file system. Hadoop is not an enterprise grade, highly available, feature rich. It's not a file system that the OS can load data from through the POSIX interface. It's not a native thing.
Right.
Um, it's a higher level bolt-on.
Yeah, and I'm glad you mentioned that because when we were talking before the show, you were explaining how you do this. And I think it's quite fascinating that you are essentially deploying an abstraction layer that sits above the files themselves and is a file system that can touch into any given file that it has access to, and then can pull it out into this abstraction layer just like a magician pulls the rabbit out of the hat, right? You
Yeah,
could
yeah.
pull it out and then use it anywhere, which really obviates a lot of the mundane ETL style data movement that we've seen historically, right?
Well, yeah, you explained it very well. We consume storage interfaces,
Hmm.
uh, file-based shared file storage, block storage, object storage, and we present as file storage. That's the most native interface. Also can present as object storage, or in the case of containers, even as block storage.
Hmm.
So think of it as storage interfaces in, storage interfaces out. And what that allows us to do is to present at the lowest level as a real file system. But what makes this truly magical is that we actually accelerate the access to data. Normally, when you add an abstraction layer, like VMware
Right,
abstracted the compute from the very computer running it,
right.
we're abstracting data from the very storage storing it. But because we have used a new architecture that came from the world of supercomputing, of a parallel file system, this allows us to actually unlock trapped performance
Hmm.
inside of the storage systems. So this is a magical case where you add an abstraction layer, which gives you the extreme agility of decoupling the logical from the physical. But in the same process, you're unlocking levels of performance never seen before in the world of NAS, network attached storage, enterprise file storage. Now
Hmm.
you get a file system that can access things in bulk parallel at unprecedented rates. That's
Hmm.
why we talk about that as hyperscale NAS.
Wow. That is very interesting because you're right. Typically, a layer of abstraction is going to slow you down.
Correct. Yeah.
But you mentioned, and this is actually very interesting because probably 20 years ago is the first time I noticed that there was this remarkable disconnect between the HPC world and the enterprise data and data warehousing world. And I asked myself, why? Like, why aren't you folks talking to each other? And apparently, you are a manifestation of what I longed for 2 decades ago.
Well, yeah, you are quite right. You had the world of enterprise file data, or NAS, network attached storage, the NetApps, the EMC, Isilon, now part of Dell, newer players like Cumulo or Vast.
Hmm.
Those the enterprise file storage um, are not as fast, to put it kindly, as the world of supercomputer file systems.
Hmm.
These HPC file systems are designed to get a kind of scale that these things can't touch. And fundamentally, by the way, that architectural difference is the separation of metadata from the data and having parallel data path.
Hmm.
Um, think of it like the difference between a DNS server and a, a proxy. Can you imagine if your domain name server that helped you resolve a Google.com, say, can you imagine if it had to subsequently proxy every last byte of traffic that went to that domain that it resolved? Your
Wow.
performance would suck. Well, guess what? The traditional enterprise NAS storage world was like that. The thing which opened the file foo subsequently has to be involved with every last IO that goes to the file foo. Metadata and data combined, control plane and data path combined. That's what hampers your scalability and performance, is that your control plane and your data plane are the same. When you
Hmm.
separate the two, you can unlock levels of performance. And that's what the supercomputing world has used for a long time.
Hmm.
But the stodgy old world of enterprise NAS has not. That's why Vast and Cumulo and Isilon and NetApp and all of these standards-based plug and play, feature rich and robust NAS have the drawback of having rather poor performance and scalability.
Hmm.
Not rather poor. very poor compared to what you can do with this separation of control plane and data path. Uh, think of it as moving to a routed model instead of a proxied model,
Hmm.
right? But if you ask, okay, why wasn't this done before? The answer
Right.
is you have to have a much more sophisticated client. The network file system client has to know how to do this routing trick as opposed to simple, you know, talking to a storage server. It has to look aside, it has to do a lookup, it has to like talk to a DNS server for data before it goes and talks to the data. It has to know how to work with this split control plane and data path. And that
Mm-hmm.
sophistication was not only difficult to build, but can you imagine having to build it for 10 different operating systems?
Jeez. Yeah.
You don't have to now because Linux won. So the
Mm-hmm.
reason why this is possible today is that Linux won the OS wars. When it comes to performance and scale, there is only one. You only have to make the one implementation, which is
Right.
why the first thing I did when I founded the company was recruit the Linux kernel maintainer of the storage networking stack of NFS. And we together built the new standard and the implementation in Linux to teach
Wow.
Linux how to work with this bifurcated control plane and data path, which allows you to then virtualize data from the very storage storing it. And all of that wasn't to unlock performance, although that's one of the ancillary benefits. The reason we did that is to unlock the ability to move data non-disruptively while you're accessing it. Massive petabyte scale data sets can be moving across different storage systems or across whole data centers. That's
Mm-hmm.
data orchestration. And as soon as you can do that, now you can have continuous uh, view of and access to data even while it's moving. And this is incredibly important when you're processing with GPUs and doing AI workflows
Hmm.
because you can't afford to have those GPUs sitting there waiting to get their data.
Right.
So GPU data orchestration is the ability to take data from existing file systems and instantly import it into Hammerspace, project it across whole data centers, and move it behind the scenes while you're already accessing it.
That's crazy. I mean, that's impressive. So you've basically freed the data for use anywhere across the spectrum of the information landscape. I mean, I often joke that some people think they don't have an information architecture. You do. There is a de facto information architecture right now in every company. It may not be very well managed or very well designed, but it's there. And what
True.
you're doing is coming in and enabling a fluid information architecture across the entire
And the
environment, right?
beauty is, it's not asking people to do a forklift upgrade
Right.
because other companies that are trying to provide systems to serve data into, say, AI, ML, large language models, multimodal models, they're saying, hey, you got to buy this replacement storage,
Mm-hmm.
right? Hey, we can sell you faster storage. We can sell you, storage that's capable of feeding these GPUs. Hammerspace is a very different story. We're saying, look, you already have a bunch of storage.
Mm-hmm.
Add the orchestration layer on top, the hyperscale NAS virtualization layer on top. And now you've got the performance and the agility to move and position the data where it needs to be and to feed it fast enough. And yet the bulk of your data can sit still in the storage where it originated.
Right.
You don't have to do a forklift.
Right.
Um,
That's a big deal. I mean, it's actually a huge deal. So I'm going to throw some comments and some questions at you, just kind of see where this goes. I'm watching this space like anyone with a sense of bewilderment. I realize how big a deal this is that we're facing right now. And these models are truly remarkable. And, I look at, for example, the business intelligence industry, and I think that most of those tools are in the crosshairs now of
mhm.
these models because they could do so many interesting things. And I think changing mindsets will be the hardest part because people do things the way they've done them. We have all these enterprise data warehouses, we have all these workflows designed. It's incredibly complex. It takes a tremendous amount of time, effort. And of course, there are errors, there are issues, there's data that gets truncated, all kind of different things happen when you're moving data around point to point. But if you can get this access layer as you're describing, where
Mhm.
it's high speed, the data stays where it is, but you can still move it as needed. Well, you just solved about 8,000 other tiny problems that organizations are already dealing with every day. Is that about right?
Yeah, the way I like to think of it is that AI is the forcing function to
Yes.
cause us as an industry to reckon with our demons of having data be a localized phenomenon to storage.
Right.
And right, we need to move past that to where data is now a global asset
Hmm.
that lives orchestrated and can be presented anywhere with local high performance access to shared global data. We have to, we're going to have to graduate from a model of store and copy to a model of living orchestrated. And we've
Hmm.
already done that, by the way, when it comes to your consumer data. You don't even have to think about it when you replace your phone or when you go between your phone and your laptop. Your data is just there. It's orchestrated for you in that
Interesting.
ecosystem. How do we do that with the unstructured, file and object data that forms the foundation of the information economy and this AI revolution?
Hmm.
That data needs to live orchestrated to where doesn't matter what storage you have here or there, or where you ought to be able to, just like this, deploy a different one, swap it out, upgrade, have it of different types. You can go between the laptop with a big screen and the phone with a small screen. You can go have your data go between a big GPU cluster where it's consuming it in bulk parallel, or some, user just plucking around with files. It has to be the same logical data that is physically distributed and now orchestrated. And so we believe that orchestration is actually the key to
Hmm.
unlocking the value in unstructured file and object data in the era of AI.
Yeah. Well, I
Copying
have.
it is not
Yeah.
sustainable.
Yeah. No,
Continuous model of copy won't be sustainable.
right. I hear you, man. And I think this is, you just kind of hinted at, or even came out and said, one of the other shoes yet to drop in this industry. And we'll pick this up after the break, folks. But don't touch that. That'll be right back. We're talking to David Flynn of Hammer Space. Very interesting stuff. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to David Flynn, CEO and founder of Hammer Space, an incredibly interesting technology. I spoke to your VP of marketing a while ago, and she blew my mind. Very, very interesting. Molly, I guess her name is.
Molly Presley, yep,
Molly Presley. She's fantastic,
extremely
and
talented.
I sit around and I think about this stuff all the time, right? So just the other day, literally less than a week ago, I was flying out to Boomi World, our big integration cloud integration vendor, and I'm just thinking about these foundational models and the history of data warehousing and business intelligence and all these things that we've tried to get to, and how these new developments impact what we were trying to do and how we can do them now. And those are two very, very different things.
Mhm,
And one of
mhm,
the thoughts I had is this concept I call the executive cockpit. And here's what I think is going to happen. I think very forward looking organizations are going to deploy probably a small language model in their data center, in their private data center. They're then going to train that model on their data warehouse data, their ERP data, their Salesforce, their CRM, their customer support, whatever trusted enterprise system data they have, they're going to train this model, fine tune it. Then you're going to set up Kafka topics from these different systems into a vector database adjacent to the small
mhm,
language model, slap a really snazzy UI on top, and that is how the executives will run their business all day. They'll ask questions like, how is our marketing working in the East Coast?
mhm,
Who do we need to hire next? Which departments are having difficulty right now? And just get all kinds of answers and then take action. Say, okay, computer, set up a meeting for all my regional VPs sometime next week. Here's the list of things to discuss, and please build some charts to show what I'm talking about.
mhm.
Enter, boom. It just goes out there, sets up the meeting, gets the people, feeds them the information. I think that's the future of management of at least large companies. But what do you think about that whole idea? Is that far-fetched, or what do you think?
Oh, no, definitely. I think it's going to take a little bit longer to get there, given the challenges between context windows, being able to, view enough data
Right,
simultaneously
right.
versus what it takes to train on it and so forth. So you're going to have this kind of a natural tension between the, let's call it long-term memory or learning, and the
Right.
short-term, attention of these systems. There are innovations happening as we speak in these areas, but I think there's still going to be some challenges with having them take over some of that role that you're talking about. But I'm stunned every day at what it's being shown to be able to accomplish. So yeah,
Right.
at the end of the day, I think you're right. These systems are going to, it's largely going to be um, interactive, uh, obviously natural language,
Right.
massive amounts of data at the fingertips.
Right.
Um, there are other potential challenges beside context windows versus trainings and fine tunings. There's issues of the um, these systems uh, making things up out of whole cloth, and you don't
Sure.
necessarily know if they're
Right.
imagining something up. So
Right.
how do you how do
Right.
you make sure it's not just daydreaming
Right.
about things?
Right.
So, you're going to have a lot of the problems that you have with humans of the fallibility of it and
Right.
how do you guarantee it? So, I don't think we can leave let's call them we have transactional systems and we have data warehousing systems. These are both forms of structured data. I think those are still going to need to exist because that's where you can prove that things
Hmm.
add up, so to speak,
Right.
right? It's not just imagining things.
Right.
Um, so we're going to have challenges with AI because just like with people, it will be fallible in that sense.
Hmm.
We're used to having computers be, when they say that the sum is X, it's X, and
Right.
doesn't mess that
Well,
up. You can't
right.
necessarily trust that with AI.
This
You
is
have
it's
problems.
because it's probabilistic math underneath, right? I mean, you're
Right.
taking text or images, converting it into mathematical formulae, vectors specifically,
Mhm.
and then converting back, sort of encoding and decoding on the other end to reflect back in words or images. So there's going to be a lossy is how they refer to it in the audio world, right? When you
Right,
take a
right,
recording of a
exactly.
recording, you get this lossy effect where you lose a little bit of the fidelity, but nonetheless, the power is tremendous. But let's
Mhm.
get into how you can enable this AI world. So I'm doing some
And
advising.
how we currently are, like
Right. Yeah, go ahead.
with Meta. They released Llama 3 just a few weeks ago. Their team uses Hammerspace in the development of Llama 3 in conjunction with their own warm storage, or it's called Tectonic. Think of it as their own object store, their own blob store. Hammerspace provides a very high performance file front end so that researchers can have the convenience of a true file system. You can CD into directories, you can LS, you can move things around, and then it's big enough that you can actually feed a cluster, in their case, 24,000 GPUs in one
Jeez.
cluster, and they're going to have dozens of those clusters. Mark Zuckerberg has said they're going to deploy 1 million GPUs. So you can imagine this is the high end of the high end of problem space, and that's why it's so exciting that Hammerspace is being proven out at that scale uh, in not just the ability to move data quickly into the GPUs as a file server, um,
Hmm.
but also the data orchestration, the ability to take uh, existing file data from multiple sources, pull it into the same logical file system by reference instantly. You don't
Hmm.
even have to copy data to get it into Hammerspace. You simply point us to those file systems, and we can, in the background, scan all the metadata while you're already using it.
Hmm.
So this avoids data migrations to get the data collected up. And then once the
Right.
data is in Hammerspace, with the swipe of a mouse and change of policy, you can redistribute the data across the physical infrastructure and you can replicate it to other data centers. And that's becoming increasingly the need is, GPU data orchestration because GPUs, go figure, they take up a lot of space and power, and they have to be racked and stacked and plug into a power source, which means that the old adage of move the compute to your data is no longer viable.
Hmm.
Data is the thing that's virtual, digital. It's what ought to be able to move in the digital. It's the compute that is physically bound to the infrastructure, to the
Interesting.
physical world. And so the old wisdom in the computing world, you've probably heard it before, move the compute to the data.
Mm-hmm.
Well, that's fine if it's just moving this program to run over here on that server. But if you're talking about a training that takes thousands of GPUs, I'm sorry, you're going to be moving the data to where you have those GPUs.
Right.
So data orchestration
That's pretty
is
funny.
a prerequisite for GPU-based computing because of the sheer scale of that compute. The
Mm-hmm.
data has to do the moving, not the compute. And especially with the challenges of getting availability of GPUs.
Right.
I mean, there's not enough of them.
Yeah,
And
Molly talked about that. Yeah, sure.
right.
Which is a problem.
And then you have the fact that it's a very bursty workload. So even if you could get your hands on them, you wouldn't want to deploy your own just to
Mm.
have them sit there underutilized. So we need a shared infrastructure model, a cloud model. But how are you going to do that if all of your data is on-prem,
Mm-hmm.
right? So if we're going to share infrastructure so we can get higher utilization of GPU clusters, now it's even more incumbent on us to solve the data orchestration issue. And copying stuff back and forth isn't going to cut it.
Right. Well,
Doing
you you're really giving me some ideas here too about how you can solve one of these other very huge, long-standing, vexing, hitherto intractable problems.
that's the exact term I use.
Is it? That's pretty funny. Which is getting a full, clean assessment of what you have of your data.
The golden copy problem actually goes to a bigger issue, and that is that if your main tool for managing data is to copy it,
Mm-hmm.
then you are forking its very existence. It's new data.
Mm-hmm.
And now either the original or the new one had better get deleted at some point, but it's hard to
Right.
do that because
Right.
you don't know, maybe one has changed and maybe the other's changed. So what ends up happening is it's like cutting off a hydra's head. It just creates
Mm-hmm.
more of them. Managing
Right.
data via copy is self-defeating because it just
Right.
makes more data to
That's
be
a quote.
managed.
That's funny. That's an excellent quote.
Well,
I'm
the
gonna
other
write
thing
these
I like
down.
is the analogy of Captain Kirk in the transporter when he gets split in two. Now, that was the
Right.
good Kirk and the bad Kirk. I guess it was the next generation when Riker got perfectly cloned, and there were two Rikers, and the second one went off to have a career and went off to whatever. And it's like, well, which is the real Riker
Right.
at that
That's
point?
funny.
What's the real data? The very conceptualization of data gets fractured when you copy it.
Mm-hmm.
And it's that golden copy issue. So you have the golden copy issue. You have, well, what all do I have? Especially when there's a bunch of duplicates of the same thing, slightly modified because you've forked it. That just is a nightmare that we can't continue to perpetuate that model.
Mm-hmm.
Uh,
Well, and I can see there are stats out there. I heard one stat that the average document is copied like 4 to 7 times or something in organizations. And there are analytical solutions that require you to take a whole copy of the data and throw it over here into their environment. There are
mhm,
digital twins, for example, that you have, which sometimes you would want to
mhm.
use for various planning purposes. Lots of different reasons why you do these things, but point being, if you can solve that specific challenge, which is gobsmacking, I mean, it's massive with
Mhm.
this layer of abstraction, that's a huge deal. And also, just in terms of what you're paying on for storage, right? Like, which data do you use? This is the other thing that's driven me nuts for years is thinking all this ETL is going around and around and around and around. I've yet to see anyone who can get a strategic view of which data is being moved where, when, such that you could understand, wait, we're doing this 7 times. Like, why don't we just move this data there and then move this data over here? Like, it's just too difficult. It's this big spaghetti monster, basically.
The beauty here is that we've had the opportunity to fix that Now, you're talking there about structured data systems,
Hmm.
databases where you do ETLs and
Right.
you move
That's
from a
right.
transaction system to a data where, right? Fine. That world, the die is cast. That's the way it is. It's okay. But the
Funny.
world of unstructured file and object data is so far behind that
Yeah.
we actually have an opportunity to do it right in a sense.
How
Okay.
interesting.
And in that world, we do it by having something, an abstraction layer that consumes storage interfaces and presents self-similar storage interfaces at the lowest level. So it's not up at an object level or an HDFS where you have to access it with Java or with REST
Right.
interfaces. It's a
Right.
true file system consumable by the OS at the most natural layer, network file system.
Right.
Um, but then what we have done is we've introduced a, a whole methodology for how to express in the data's metadata what the data needs from its physical environment. What level of performance, what level of reliability, what kind of data sovereignty. This is actually allowing data-centric
Wow.
data management through its metadata. So the data actually becomes, let's say, more self-aware of what its requirements are for its infrastructure. Because frankly, the world has been upside down. We didn't actually manage data. We managed storage systems and we copied data into it. So we
Hmm.
manage data by copy and it magically gets the capabilities of the storage system that you've put it into. That's very tail wagging the dog. The
Mm.
infrastructure is um, a lower level abstraction, not as interesting. What people need to focus on is the data layer. And yet, the very organizational structure of the data, what data is next to what other data in the same file system, in the same directory, that in the past has been more dictated by how you're going to pack it onto the infrastructure, which storage
Mm.
you put it into. That's the major sort. This data has to be in this group because it's going to go on that storage. This data has to be in that group because it's going to go on that storage. That's the tail wagging the dog. In a
Mm.
hammer space world, your structure of the data, the directory structure, the file system, is a logical thing independent of the physical layout of the data on the infrastructure.
Mm.
And so this has allowed us to create a metadata driven data management model, a data centric data management model.
Wow.
And by the way, it's a declarative model. You
Oh,
state what the end goal is, and the system can figure out how to place the data to achieve the stated goals. In other
wow.
words, and here's the beauty, we are allowing AI to solve the problem of where to place and when to move data so as to achieve the stated goals of having the data where you need it when you need it,
That's,
which is a key thing for running AI workflows.
yeah,
So using AI to solve one of the biggest challenges for AI, the management and placement of data.
that's amazing. We're going to pick that up right after the break, folks. Stand by. You're listening to Inside Analysis. All right, folks, back on Inside Analysis, a fascinating conversation with David Flynn. He is the CEO and founder of Hammer Space, one of the coolest companies I've come across. They're just going ahead and solving one of the longest standing, most intractable problems of data and using data, and not just structured data, as he said several times now, unstructured data, all the files, all the memos, all the PDFs, all the contracts. And what I think is so
Images,
fascinating.
video, rich media.
Right, rich me all this stuff. And let's face it, managing that stuff historically, absolute nightmare. Okay. Never really has been done in any strategic sense. I mean, someone is responsible for it, but it's just very difficult to do. But when you can define policies and then change those policies like data sovereignty, for example, and maybe let's get into this additional metadata that you have on the data, which captures where it is, what it's adjacent to, what it is likely to be used for, things of that nature. It kind of reminds me of in Parquet files, so you've got that first little block, which is
Uh-huh.
designed for analytics, right? It sounds to me like you've done something similar. We've got that first little block, which is the about me of the
Mhm, mhm.
data, right? And then you can define policies based on that because it's going through one abstraction layer. So it is a choke point. It's just a very fluid and efficient choke point, right? Explain that if you would.
So the term that we use is a service level objective.
Mhm.
Service level objectives are of various different types. They can spec a desired performance level, desired reliability, availability, durability. They can express sovereignty constraints. Where is it allowed to be? Where is it not allowed to be? Where do you need it to be close to get good performance? Where do you need it to be at a safe distance from to get, failure independence for disaster recovery? All of these expressions are service level objectives.
Mhm.
And those service level objectives are intent. It's like they state an end goal, not how to get it, which
Mhm.
allows the system to figure out where to place and when to move the data so as to best achieve the stated intent.
Hmm.
Declarative is much more powerful than imperative, than
Right.
procedure,
Sure.
uh, because it gives the degrees of freedom for the system to do it. And that's where we're using internally machine learning of the system to make placement decisions and movement decisions about the very data across the infrastructure.
Mhm. I
But
mean, it's kind of like a data operating system is one way to look at it, right?
yes, yeah, that's a term that that I have often thought of for it. Data operating system, uh, DOS.
Mm.
That was a disk operating system. We go
The
back to
new
DOS, actually.
DOS.
Yeah, yeah. So, well, and funny thing is, DOS, disk operating system, it was the mapping and managing of data on a single disk drive that was sort of defining of that early OS. And then we managed data across large arrays of drives, a RAID
Mhm.
set, and then a
Mhm.
storage array. Well, Hammerspace takes that progression to the logical conclusion of mapping and managing data across all forms of storage infrastructure
Mhm.
and yet still presenting it as a file system
Right.
at the lowest level that the OS can consume. So you really could talk about it as a data operating system like that. It's just what needed to have been built to support. Think about what this means for cloud computing,
Mhm.
because now you have the potential to run anything anywhere without having to care about data gravity.
Mhm.
Because data is no
Wow.
longer localized, cloud can finally live up to that notion of I don't have to care who owns or operates the infrastructure. When data is localized, you have to worry about that. You're a prisoner to your data. Once you put your data in US East, all of your computing needs to happen there. You can't even run it in US West. Yeah, it's AWS, but it's even specific to a given region of the cloud. In other words, cloud computing today is just back to the future of the mainframe.
Mhm.
They're just big mainframes.
Interesting.
We need to move to a world where data is orchestrated so that we can have a truly utility model of computing and be able to run anything anywhere.
Well, and so let's talk about governance, data governance. I'm
Mhm.
old enough to remember when we talked about this 20 years ago, and it was really just kind of a joke because there wasn't a whole lot you could do. I mean, you could control access at the database level.
Data
You could,
governance is a farce in a world where your main tool for managing data is to copy it.
right, right.
It's
That's
copying it
right.
is open Pandora's box. You
That's
never know
right.
where the
That's
data
right.
is.
No, that's right. So, I mean, do you have the capacity then in terms of data governance principles and practices to once you're initiated and installed to achieve data governance?
That's absolutely. Once data is in Hammerspace, it's behind the facade of the file system.
Hmm.
You have a single access control layer. If I change the permissions here, it's changed around the world and nobody can
Wow,
access it. I have a single audit trail. If I turn on audit, I can tell who's accessed it anywhere.
that's
And
amazing.
because the data can move within the file system, that means you don't have to allow the copying of the data. As soon as you start
Right,
copying it, you lose control of it.
right,
You can't change the permissions here and have it change there. That copy is a different thing, right? You
right,
can't put on audit here and have it audit that copy over there because that's a different thing.
right,
So we have to move to an orchestrated world so that we can put things safely behind a single unified presentation and access layer so that you can audit that access, so you can control that access, so you can
hmm,
put policy on where the data is allowed to be, where it's not allowed to be, where it must be. Those sorts of expressions are service level objectives.
Yeah, I like that a lot, by the way, the surface level objective. That makes a lot of sense because to your point, you do have objectives in business, especially with the use of data. We want to control the use of data. We want to get certain pieces of data to certain people in a more timely fashion. I mean, that's the usual use case, but also the governance side is incredibly unwieldy. And to your point, I've always thought this too, unless you have a choke point, unless everything goes through one point, virtually or otherwise, you don't have data governance,
And that's
right?
the beauty is that this, it logically is one, but under the covers, it's a true parallel file system
Hmm,
inspired from the architectures in the supercomputing world, which
right,
means it doesn't choke your performance, it actually unlocks it,
right. That's crazy.
right?
I
And
mean, that's,
so here's the other truth behind this. In the past, unstructured data especially had a human in the loop
mm-hmm,
because images, documents, for those to really be useful, it's a human who had to view it and interpret it. Until
mm-hmm,
now, with AI,
right.
machines can finally comprehend what is in this unstructured data.
That's
And
crazy.
so, what that means is that
Right.
we're no longer limited by the bandwidth of the human interface, uh, human comprehension. And so, these unstructured file and object systems that used to be bandwidth bound by by people in the loop, it's now machine in the loop. And it'll go as
Mm-hmm,
fast as you can feed it. And that's why we have to go past the old world of NAS, mainly to
mm-hmm.
support a file share for people to collaborate in and to muck around in. Now we need file that can operate unfettered at the full performance of machine to machine.
Well, and this is something I'm always trying to think of applications of technologies, but a company called Microsoft, which has SharePoint, which I've never been a big fan of SharePoint, to be honest. Once I understood what it was, I'm like, all right, so it's basically a sort of like a file system on top of all your stuff to give you access to things. The controls, the permissions have always been very wonky to me, at
Because it
least, just
wasn't
kind
a
of
real
slow.
file system. They
Right.
built
That's right.
a faux file system on top.
Right.
It's a faux file
That's
system.
funny.
By the way, the same is true for Hadoop. The same is true for S3. These are all faux file systems.
Interesting. So my point being, if Microsoft were to go ahead and partner and buy Hammerspace, they could finally solve and live up to the vision of what SharePoint was supposed to be from the beginning, right?
And it's not just Office applications, Microsoft Office applications. We're talking about in the world of media entertainment, you
Right.
know, building assets for making movies. We're
Wow.
talking about chip design, designing and laying out microchips. It takes huge amounts of data and a lot of high speed. Talking about industrial design. Blue Origin, Jeff Bezos' space company,
Wow.
uses Hammerspace across all of their facilities for the industrial design, for marketing, for the telemetry gathering, basically, and as the way to do hybrid cloud.
Wow. That's
So
crazy. We got the podcast bonus segment coming up next here, folks, in just a minute. If you want to be on the show, send me an email, info@insideanalysis.com. That comes right to me. We're here to explain what's happening in the technology and data space, how that affects you, how that can help your business. This is just an absolutely fascinating conversation. One small segment left. We'll be right back. You're listening to Inside Analysis.
great.
All right, folks, time for the podcast bonus segment here on Inside Analysis, a fascinating conversation with David Flynn. He's the CEO and founder of Hammerspace. And Hammerspace is the space out of which magicians pull things, just so you know. That's what it all means. But so I'm going to throw a use case at you, David. I've been around long enough to remember actual cameras with film, and you processed. And of course, you were very careful about what you snapped because you had to pay to get it processed. And now we have a completely different world where instead you have thousands and thousands of pictures and someone's going to, oh, I'll show you my kid, and they're like scrolling and scrolling and scrolling and looking for something. I'm guessing with your technology under the hood, and I think Google may have something similar they're trying to do, I'm not entirely sure, but I did notice that you can now search in your pictures like dog or
Yep,
grass or
yep.
something, and there's some metadata that has obviously been captured by an algorithm that scans the images and finds things for you. That's something you'll be able to do, which is incredibly useful in the creative arts for like knowing which picture to find, knowing which picture or which image or which movie, or knowing where in a 2 hour
Mhm.
segment of video you show up. That's the kind of things you guys can now enable, right?
Eric, I'm impressed. This was actually one of our early demos, was throwing data into Hammerspace and having it automatically orchestrated like Lambda functions through
Hmm.
image recognition and then tags gathered. And then you could say, oh, by the way, I want all of the pictures that have this person in it or this
Right.
whatever. I need that orchestrated to this site. So you just made up out of your own mind what we used as one of our first demos for this enhanced metadata and metadata driven workflows, um, because
That's
it's really cool
amazing.
that that metadata comes through image recognition and
Right.
determining what's actually in it. Yeah.
Right.
So
Yeah.
yeah.
That's very I mean, there's so many use cases. I mean, you've really unlocked, yeah, and I'm in the data space. I've been in this space for 25 years now, almost. So it's hard. Unlock, unleash, unfetter, all these words we use all the time. People are like, okay, sure, unleash my data, blah, blah. No, you're actually doing that. Like you've
Yeah,
actually
it's
set the data free.
this has been a long-standing dream, to abstract data from the very storage storing it at the lowest level data interface, the file system. But attempts in the past have failed miserably because it requires a new architecture, this separation of metadata and the
Right.
control plane from the
Right.
data path, like that's done in the supercomputing world. And that is very hard to do, especially if you had lots of different OSs, because you'd have to do
Mhm.
it in every single one of them.
Right.
But now with Linux, you do it in one place, everybody gets it for free. This is already built into Linux. Every
Yeah.
Linux box out there now knows how to interact with a hammer space.
That's outstanding. What a great way to do it. I remember when I first understood open source, and we're talking 20 odd years ago, I was doing some research, oddly enough, into transparency in federal spending, which I
Mhm.
argued back in 2005 could actually absolutely be done. The technology was there, the data is there, the Sarbanes-Oxley Act mandated that corporations document their processes and all this stuff. And I thought to myself, if corporations have to do that, why doesn't the government do that? So I got on this
Mhm.
big high horse and evangelized all about
Yep, yep,
transparency in
yep.
federal spending. And lo and behold, a couple people paid attention. One guy in DC, Mark Tapscott, who went and testified before Congress using the term I gave him, which was citizen auditors. And they did it. In
Uh-huh.
2006, Bush signed the Federal Funding Accountability and Transparency Act, co-sponsored by a guy named Barack Obama, who was then a senator from Illinois. And
Mhm.
we began that journey, but we're still not there, but we're going to get there. And I think if Hammerspace is in the mix, it's just going to be tremendously powerful to show the world what's happening. Because when people know what's happening, they have trust. If you don't know what's happening, that's when mistrust can kind of creep in. But you're giving this access to all the data across these highly disparate environments. That I think is the key to really opening the door to a
And,
future trust.
and the magical part is, if we move from a world of store and copy to a world of orchestration, data is actually more permanent, not less.
Wow.
Because you lose the permanence when you start copying, because
Yeah.
you lose even track of what is the real data.
Right.
And even when it's stored, you lose it, its lifetime is limited to that of the storage.
Wow.
So it's really kind of bizarre to think that in a data orchestrated world, your data becomes more permanent. When was the last time you had to worry about your photo
Right.
library?
Right.
It's orchestrated for you, it's more permanent.
Right.
Hammerspace is making data more permanent than the very storage storing it by abstracting it from it and allowing it to move automatically across storage over time. And at the
Wow.
end of the day, people are going to look back in as little as 5 years, maybe it takes 10 years. They're going to look back and say, this was obvious. Somebody had to do it.
Yeah.
But the
I
truth
get
is,
it.
it had never been achieved because it required an architectural pivot away from a monolithic model, a
Right.
proxied model, to a routed model, a DNS lookup like model for data, and that hadn't existed. And introducing that lookup like model required the consolidation of OSs down to Linux being the winner so that you could make these enhancements.
That's awesome. Thank you, Linus Torvalds, and all the people
Exactly.
who were. Thank you, IBM, for investing $1 billion in Linux years ago. Well, folks, look these folks up online. Hammer Space, absolutely fascinating, game-changing company. David Flynn, thanks for your time, folks. You've been listening to Inside Analysis.